So we cover these topics today. What exactly we mean by a database and database systems, and what exactly we mean DBMS. Is it a hardware or software? Bear with me, there is some garbage collection van. So it's quite common in Bangalore. I don't know about other cities, but generally these times, the people come with heavy speakers. They will go away soon. No, so just few seconds. Yeah, database system environment. So we have a diagram, block diagram, which explains about what are the various other components. So part of this database system, and this is a very interesting and important topic. That is, advantages of DBMS over that is we call as early file systems versus DBMS. Early file system include maybe the Unix or Linux those days, are now Windows based file systems like the folders, which we talk about today. So you store your files in folders or Android or any kind of operating system. So how is it different from DBMS? And then the basic architecture of any DBMS is called as the three-schema architecture. So we have three layers. So we will explain what exactly each layer has. And program data independence, there is this one. So I can use these pen. Yeah. Okay, so this program is called as program data independence, which is nothing but, it's not hard coded kind of thing. The data is not bound with the program. So it is kept separate. So that's a separate entity, and it's not tied with the program. So what is the advantage? In fact, this is one of the characteristic feature of the database. Then structure of the data users, who are all the people who use and the various data models, like the hierarchical model, network model, you know, relational model, etc. So there are various ways by which we can store the data in the database. Okay, now quickly, before we go into the slides, uh, we all know about data. We talk about big data also, Facebook, Twitter, etc. So data may be generated from various sources. For example, you talk about IoTs nowadays, Internet of Things. So data comes from sensors, or the data might come from satellite, or the data might come from. Yeah, another important instruction which I forgot was I'll just share my mobile number. So in case if we get disconnected for some reasons, or so we have a lot of data which we think of the data coming from, as I said, IoT kind of devices, sensors, or it could be from healthcare, or it could be from users, banking kind of thing, or government, where again citizens. So data is all over our day-to-day kind of life. Banking data, the banks use for the customers in order to give the service. So people, the customers can withdraw or um, deposit amount or fund transfer. All these kinds of things is possible for the customers. So similarly, the data, once if it's obtained, has to be processed. Okay, so data is one, which are nothing but the known facts that can be recorded. As I said just now, it's stored somewhere, and then we try to process this data for some reasons or the other, maybe to extract knowledge or to provide some service, as I said, the banking or the government may want to extract some information from it. So when we try to process this, then it becomes actually information. So the data will try to be processed. They'll try to process in a particular way in order to get some knowledge or the information, because raw data may not be useful. For example, ECG data. see that data comes, or that is useful only when it is processed and some information is drawn, and so that the doctor can diagnose. So that is true for all kinds of medical kind of equipments which produce a lot of data. So what is a database? Database is a repository. Basically, it's a storage. Okay. So it is a data. It is not a device. So like a storage device, we call it, could be hard disk or otherwise. So this is nothing but a schema or a way by which we organize the data in order to store it in a better way so that it could be retrieved. The way in which it is stored and retrieved, it depends upon how you design this database for a particular kind of application. So this is highly structured in the normal databases. It could be unstructured also in the NoSQL databases. I'll come to that later. So that's a separate subject actually, which does not follow any particular predefined structure. But here it is pre. So how do I store my data? By following certain structured way. That means certain format, certain way by which, because we can organize the data in many ways. I can just write it down in a piece of paper also. So that's how I get my data being stored. So you can just go through the sheets and then get, or I can store it in a file. Right? Notes, for example, you get in a mobile phone. So there are a lot of notepad, Windows operating system. So we can just put this data in many ways, but here in database, we have a highly structured way by which we can organize our data. That means put the data into the storage devices. It is not storage device. It is the way by which we organize. And ultimately, these databases in the physical point of view, it's ultimately going to be stored in the form of files. OK, so don't get confused. So this is in the user point of view. We don't talk about files. We just worry about only the way by which it is organized. And well, somebody has to monitor, somebody has to manage this entire database. So which we call it as DBMS, Database Management System. So some software. So DBMS is a software set of modules, and it can handle or manage users. It can manage data. It can manage resources, etc., etc. So a lot of components. So the architecture of DBMS is very big. That we'll see later. So DBMS is a software, and it's a convenient way, or it might provide UI for the users to interact with the DBMS or the database application. So there are two things now. One is the DBMS, which is a generalized software like Oracle. I'll show you some of the examples in the later slides. Oracle is very common, MySQL, etc. So these are some of SQL Server. So each company has its own database management system. So this is a software which is used to manage the entire database. So database is constructed for a particular application and using DBMS software. And DBMS software also helps in order to retrieve, store, manage, etc. So it's basically a software. So it's a relatively large, all that. It's OK. A modern database system is a complex. So don't think that it is small. In fact, we have paid a lot of money those days to purchase even Oracle database management system. Similarly, Microsoft SQL Server. Those days it was, very, very costly kind of affair. Now I think cost has come down. Some of the medium-sized database management systems are cheaper. I'm sorry, it's free actually. So you can download MySQL or some of the NoSQL databases also freely. OK, so what is a database? Formally, we can define that is a shared collection of logically related data. So when I say it's not simply, database is collection of data being organized for a particular application, but it should be also shared and they should be related, logically related, not necessarily physically. because the data may be scattered in the disk stored, but logically all are connected because I can have many databases. One database for student, I can call it a student database. Another may be employee database. I may have e-commerce kind of thing like Amazon. I may have products data, customer data being stored. So that's a different database, etc. OK, so data, as we already said, it's a raw, facts about something. It could be customers, it could be products, it could be anything. OK, the simplest database, which normally I would say that in your mobile phone, your contact list, right? So you have a particular structure where you have the name, phone number, email ID, address, etc. So for all those contacts, your friends and relatives, what you store in the contacts of your mobile phone as the similar structure. It's not different for each entry there in the contact list. It's common, right? You may not enter data for certain things, but the structure is same. So that is the schema or the structure of the database. So it's a database where it shows the data of various contacts. OK, this is my instructions also. I thought it's a new one. OK, right. So we will continue with this because this subject I've been teaching for a very long time for BE and MTech students of regular program, our BE and MTech of VTU. And even prior to that, Bangalore University, and many other universities like Manipal and other universities also. Those days I've handled, and I've written a textbook also on database management systems, just like DSA and analysis of algorithms. So this also I had written, and now I have stopped writing books or updating it because now I made it as ebook. So I'll just share my book also, the ebook in the PDF form. So you can go through that when you get time. But otherwise, the PPT is more than sufficient. It's quite elaborate. And many people have contributed for this. I have contributed for a couple of, class schedules, topics, normalization actually. And we all in our regular program like BE, we have a laboratory along with that project also, that is mini project. We call it a database project. So people used to develop database applications using Oracle or MySQL with a lot of web related kind of tools like PHP or Python and Visual Studio Code, etc. So they have to build or develop a complete database application for a specific domain. OK, so that's what I'm going to come to you in a couple of slides. So database is nothing but it's a collection, shared collection of logically related data. So it is being defined using some data model. So how do we build or develop or get a database being built for an application? It's through some data model. Generally, we use relational model. OK, so that part of it anyway, you will understand as we proceed. So data may come from, many places, as I've already told you, could be facts from statistics, values, figures. So you can add anything here like sensors for IoT, or it could be from government kind of thing or healthcare, etc. So this is going to be stored in the form of database using DBMS and in the storage. So database generally shown in the form of a disk because ultimately my database is going to be stored in the database. So we call this a database in the storage. So it could be employee data, which is stored in the storage called as the employer, or it could be students. So student database. So a lot of, database systems which are used, as I said. So what are those systems? OK, before that, I think, OK. Yeah, so these are some of the database systems. I'll come to this after this database management system. So we know what is data and now database management system. So The raw data comes with strategy, as we already said, and it's all stored or uh, it is built as a database and stored in the disk with the help of DBMS, which has it has storage, retrieval mechanism, administration. You can admin and you can generate reports. You can send in queries. It has a lot of security systems built in. So DBMS provides all these characteristic features that people can actually use this in order to build. Because remember, database once we store, it's more sensitive, or it could be financial oriented. So something, I mean, security point of view has to be embedded. Otherwise, it's not like anybody can meddle with the data. No, even if it's empty database, certain things only people can see, but certain things cannot people cannot see. Only authorized people can see. So it should be highly secured. So for a ordinary user, for an ordinary user should be able to interact with the database application, which has already been built using your DBMS, and should be having proper UI, and the entire logic has to be made available. So this is a simple environment where you can see here that we have the stored database definition, which is called as metadata. That means information about information, the data about data. I think we have already talked about this earlier also. So meta information is nothing but not the actual contents, but it's the meta information. That is, for example, if you take Windows operating system, we have a file. So what file contains is the data, but the details about the file itself, what is the file name, when it was created, who is the author, all these are called as the meta information. So that you can easily get either Windows or Android or Mac. So this is the actual data being stored in the database in the form of files. So it is all stored in the disk. So in order to access this, or not to monitor, not to manage the entire database, we have this database management system, which is a software, could be Oracle, etc., as we already seen. So software to process queries, software to access the stored data. So we have a lot of modules. I'll come to that later. Elaborate architecture of DBMS. So this part of it is called as the application programs. That means we develop programs or the UI so that users can actually use this because they're not aware of how data is stored in the database and what kind of format it is using, commands, they're not bothered. All that they want is simply make queries, maybe in the form of searching or clicking some of the menu items, etc. So any software you see, any application you see, for example, could be banking application. Assume that you are a ICICI bank customer, you have iMobile app, or you have an application which is web-based, or it could be COVID, which is a vaccination kind of government which has developed an application. The users can actually register for vaccination. And you also get the certificate you can download. There's a report generation. So people have many ways by which they can actually interact with the database. So we have the, as we have just now seen, these are the top level where users who will interact with the database via what is known as SQL. SQL stands for structured query language, where we can generate or write queries in order to retrieve or modify the data which is stored in the database. So there are several commercial databases like Oracle, MySQL, MongoDB, which have NoSQL, SQL Server, Microsoft, Maria, IBM has got DB2, Microsoft MS Access. So popular ones nowadays are MySQL, Oracle, SQL Server. So these are the SQL based databases. NoSQL based, you have MongoDB and Neo4j, so many other things over there. Right. So the functionality of the database, define a particular database. How do we actually create a database? construct, load that into the database, because these are all available in the form of, as I said, in the form of commands or queries, or uh, the database administrator will be able to handle certain things. So you will study all that in SQL. There's a separate module for that. For example, you can retrieve using sending queries. You can modify again by SQL statements through web applications. So you have a lot of tools nowadays available. For example, you have Python based web application development, where the backend could be your database using Oracle or MySQL, etc. So you can get connected to your database via so many high level languages. So I'll come to that later of how a database application could be built. And then process, share, protection. That means security, visualize your data in the form of many ways and maintain, because generally it's a tabular column which you normally see, or it could be a plot or so many things. So can be used for many purposes. So to give you an example of a university database, so we talk about what is known as a mini world. So what is the meaning of mini world? So you have a very, big globe world we have. We have so many problems in this, so many domains. I talked about, for example, you may have healthcare, you might have university kind of thing, you have library, you have travel industry, you have government, correct? So you have so many kinds of domains where the data is collected, maintained, and users are going to use this data for some purpose. Okay. Many problems or many domains where the data would be generated, ultimately being used. Now in this, assume that I am interested in university related kind of data. So this is mini world. So this is big world or normal world. This is my mini world. I'm not bothered about hotel management or travel industry. I'm not worried about the, government kind of thing, as I said, COVID or other things. I'm not worried about banking kind of thing. Banking and university, there's no connection. So this is a separate problem, separate domain. The data generated, etc., is totally not connected to this. So when you develop a database application, okay, so we focus on a mini world. So what is the data generated here? And how do I manage and what kind of reports I can generate? So I just focus only on this particular mini world, right? So any database application being developed is normally is developed based upon this particular thing in mind. That means that what are the various entities? That means what are the various things which are going to generate data for me in order to make sure that I can involve all these things in order to build my database application. For example, when I talk about university database, could be students, could be courses, sections. So these are all connected to my university data. I don't call this as like transfer of funds. No. Depositing some amount in the bank. No, it's not a bank. It's not a bank. It is actually a university database. So you're more worried about only that. Okay. For instance, this is just an instance of what kind of data which it might have, which is shown in the form of what is known as a tabular column or a matrix form. For example, student, I may have some data about student like name, student number, as I said, the contact list. Similarly, I may have grade. So all these are pertaining to a university. University had to generate the grade report or the course details, what it's offering. Sections would be college details under this university affiliated kind of thing, or it could be like campuses, so many details which are part of this university should be maintained. So these are some of the tables where I have stored the data pertaining to university in 5 different tables. So how do we describe the characteristic features of this approach of data? So when I say it's an approach, that means I'm just storing my data, which is generated by the university related kind of entities in some form. So how do I describe this approach? In using what parameters I can just describe this. So that's what this slide talks about. And of course, the subsequent slide also. So each one is connected to some figures as well. So self-describing nature, a DBMS catalog. So that's why I said, the meta information about this. That means complete. I'll give you, of course, the okay. So we can think of the meta information of various data being stored. For example, would be student, as we already showed in the previous this one. So student name. So what is the meta information of this? How many columns are there about student? What are the names of the columns? What is the data type? What is the size of each one? So many details about that, but not actual content, whether it has Smith, Brown, John, Scott. It's not that. That's data. So meta is nothing. Metadata is nothing but how many columns are there? What is the size, data type, etc. So it's also called as a catalog or metadata. Installation between program data independence. I have a separate slide, so we'll talk about it. So in simple terms, that we normally try to decentralize or detach the data from the program. So it's not hard coded kind of thing. In the sense, data is not bound to the program. So this is what I said, the catalog information for the entire database called as university database, how many tables are there, and each table, how many columns are there. Where is my cursor? Okay, my cursor. Okay, now this one. Because the cursor is now a dot. Okay, so this is my relations. How many relations are there? What are the names and how many columns for each relation is given? So similarly, I have my okay, getting my mouse is ready. Columns. So when you take the column details, you have the name, student number, as I said, the type. So this is what called as the meta information. Then we have what is known as abstract definition or abstract details of the database itself. So that is through the what? Through the data model. Okay. There are several data models, like as I said, relational model, hierarchical. So the way by which the details of the data, the conceptual view of the entire database is seen. So it's simply that I'm able to store my data in a tabular column, which we call it as a relational model. Okay, that is rows and columns. That's all. You can store the same data in a different way, like hierarchical or network. So each one has its own merits and demerits. So that is called as your data model. And it supports many views. That means once if I store the data in a database, I can just view it in different. That means you can focus on student, and reports. You can get or retrieve data from what people have done, students, which courses they have done, under whom, instructor did. So you can get views of various things depending upon your requirement. And you can share the data, of course, with the concurrent users, etc. So you can process the data. It's called as OLTP, online transaction processing. On the other hand, data mining you'd have heard of, it comes under OLAP, OLAP, online analytical process. So that is past data is processed, whereas OLTP is current data being processed. So we are more worried about current. For example, you want to place an order in Amazon, and that is current work, that is online transaction. Or you want to transfer funds from your account to your friend's account, maybe through Google Pay or Paytm, all that. Yes, that is online transaction processing. So these are all the database applications which are being developed in order to make sure that it provides some kind of facility to the users, right? So the data is stored in the database. To build the database, DBMS has helped me. And putting all this together, I have some tools which can be developed as a separate database application. So we have three things here. One is your database management system. You have database and you have an application, database application. For example, you want to book a ticket in order to travel from, say, Bangalore to Chennai or Bangalore to New York. So you just go to MMT, that is Make My Trip, or you go IBIBO, cleartrip.com, etc. You have a clear cut UI being provided to you. So everything is available. Once you log on, yes, you have offers that the UI or the view of the entire thing is available to you. But what does the ClearTrip or your Amazon does? He has developed a database application in order to store the users or the customers, in order to store the products, to give a clear view, queries. You want only the iPhones to be listed and then make transactions. See, this is your online way of doing this. So complete application is developed mainly to do this mini world. So this is the overall idea of the entire database. So it's a real world kind of a subject where what you see or what you experience or what you are as a user. Now you are going to be like a developer, right? So view everything in terms of a developer, how it could be done. For example, you want to develop your own database application and then something like, say, Amazon or Flipkart. Yes, you can do it. OK, early file systems versus database management system. So why people have developed this? They could have just lived with your early file systems, what was available maybe through Linux or Unix and then Windows, all that. No, there are a lot of disadvantages, as we'll see. So this is the left hand side figure. OK, there is my cursor. Yeah. So this whole thing is the early file system. So I have my application for some purpose for which the data is stored in my file. So I just access this from these files. I have another application where I may have a different format, etc. So I have to define that with a different way. So I have this separately. For application C, I have separate. So this is the kind of things which we have in the early file system. There is no unified model which will help me, irrespective of the application. My data is stored at one place. So that's what the database does. So my entire data you can see here is stored in the database, irrespective of any. So I can have another application. I'm not worried about what format I have to use, whether it is Linux format, etc. So you would have seen that the client point of view. See, I can just interact with my Amazon or Flipkart either through my iPhone or my Android phone or through my Windows operating system or Linux based. It is nothing to do with that. So the data is stored at a unified kind of manner, which is stored in a particular database, and any application which we are talking about it's able to interact with this database, and it is all available at one place. And that is being provided by using some database management system. So it's an integrated database with the DBMS. The applications are free from its development. So I can just develop any application irrespective of this. For example, I can get connected from Python to Oracle or Python to some other database also. So even if the database, of course, any application is built by using a particular database management system. So we don't switch between databases. So many organizations may stick to, for example, Oracle or MySQL Server, etc. But applications could be many. So I can develop many applications and store my data. That anyway, I will show you some of the examples which I have developed for part of my, regular BE course called Database Management System mini project. So you will be able to see how it's developed. Generally, I was doing it with PHP and HTML, CSS, Oracle, and then MySQL. Then I have switched over to Python in the recent times, because Python is so popular now and it's so easy and faster to develop applications with MySQL. MySQL being free, Oracle is also free, but MySQL handling is Workbench is there, so it's very easy. Or and the IDE is of course Visual Studio Code, so you can switch. You can have HTML, CSS also there. You can have Python. You have a integrated built-in web server. So all in one, and you just to open your Visual Studio Code, you can develop any complex database application. So basically why the file systems have been dropped is because that data may be stored at multiple places, called as redundancy, difficulty in accessing data because of different formats and indexing, all that, and multiple file formats. As I said just now, it is, like different applications may, different formats, uh, because of which it is not so easy. So you may have to change the program in order to access a particular file format. So those things are not there here. And integrity constraints. OK, for example, account balance gradient become buried in program code rather than. So it's all done in the SQL level or when you build the database itself. Hard to add new constraints or change the one in the early file systems. So though it is easy, but it's not going to work for complex or medium kind of applications. Similarly, you can have atomicity of updates. So failures may leave database inconsistent with partial updates. We'll talk about this later. Concurrent access is also very easy. Security problems, all that. All these are removed in using the database approach. So you can control the, it's not that removing redundancy, you can reduce redundancy or you can control, because 100% you can't remove the redundancy. Some place you have to repeat. Unauthorized access also you can eliminate because you have very strong, security system which can be embedded into your system. Right. Providing persistent storage. In fact, DBMS really talks about persistence. So once you store your data in the database, it's there forever. You don't need to worry. OK. Providing storage structures, indexing to make it more faster, primary indexing, secondary indexing. There are a lot of things. So there's a separate chapter on that. Backup and recovery is very easy. You have the, as I said, workbench. You can take backup very easily. I have done it many times. So you can take the complete schema, that means the complete structure of your database, and store it somewhere. And if something goes wrong, you can recover it. Because backup and recovery is very important in many systems, even for your mobile phone, WhatsApp, for instance. I don't know how many of you have initiated this. So for example, storing a backup schedule can be programmed, maybe weekly, once, daily, all that. So in case of either changing phones or something that you want to factory reset your phone, and then you want to get back the entire chat backup, yes, it's possible, provided you have backed up your chat history. So similarly here, the data is most important one. So backup and recovery is also provided very easily. Multiple interfaces to different class of users. This comes under your development. Complex relationships we can establish depending upon the business logic. Enforcing integrity constraints, again, depending upon very complex kind of database application. So remember that the present day applications are very, very complex. They need clients need lot of things. For example, being in Wipro, I think most of you will be developing applications for your clients, maybe in India or abroad. So they have lot of restrictions, constraints. So all these can be very easily incorporated. OK. And you can enforce standards. You can reduce the application development time. Very easy. Visual Studio, not code. Visual Studio 2012, I think. Sorry, 2023 also would have come by this time. You have a lot of templates, and everything is integrated, available at one place. So you can just get these templates and develop and customize for your purpose. And it won't take much time. It's very fast. You can develop. Flexibility to change data structures through SQL modifications. Schema changes can be done very easily if at all it's required, but otherwise it doesn't change once you design for a specific application. Availability all the time is there. That's why nowadays, mobile phones very handy that you can access from anywhere. In fact, now 80% of the people transact through mobile phones. That's why you have this payment kind of applications or food delivery kind of applications. All these applications are helping the people in order to lead the library. So without database, nothing works. So the entire world, is dependent, or it's more relied on this particular database. Database schema includes definition of database. I'll come to the schema definition, subschema, later. So schema of a database does not change, as I said just now, because once you design the structure of a database, for example, university or e-commerce or something like that, normally it won't change. You can add data, you can modify the data. That means that is data manipulation, but not DDL, data definition. So we have languages like DML, DDL, SDL, VDL, all that. DDL is data definition, which is mainly for defining the schema or the structure of the database. That means how many rows should be, how many columns. Rows, of course, it's nothing to do with schema. I'm talking about the columns. So data type, size, etc. So we don't add columns. Once you define a schema, so basically it remains forever. Unless you require additional kind of thing, which is also possible by using alter table command. Instance is the rows. You can add rows. That means today it may be 100 rows, tomorrow it may be 200, like that. That means today you have purchased only 10 items from Amazon. You can add into your cart some more. So that table will increase. So the instance of the database may keep growing or shrinking. Now we have the three-schema architecture. This is the simplest one. That is, it has got three layered. Layered architecture you have, I think, should have studied already in computer networks. So we have three levels here. OK, so we have the lowermost one, the database. This is called as the physical level. So this is your bottom. It's a three-layered architecture or a three-schema. So this is one. So this is two. This is three. OK, so physical schema is nothing but the storage details or the database. Logical level or the logical schema is nothing but the conceptual level. That means how people view the data in terms of names, but actual storage details is the physical level or the internal level. The top level is called the external view or the external level, where people can view the data in different ways. So that's why you have different views. To give you an example of how does it look like in each level, I'll just skip these things because. OK, so these are the information which may be contained in each level for, let's say, a book or a library kind of a management system. Now we can see that the lowermost level, it gives you the storage details of various columns which are part of this database application, where our database, where I have my byte level and where it is stored, which sector or which block, all those internal details of the hard disk will be available. But conceptual level, we are not bothered about all that, but we are more bothered about the names of each column, right? And the size, data type and size. This is useful for creation of the database, that's all. But otherwise, we will access through category. So that is the conceptual. So this is the abstract level. So the actual details, where it is stored, how many bytes it has taken, all those things, how they are connected, the constraints, all those are part of this physical. The meta information also will be there along with this. So the conceptual level has only these. External, as I said, I can have a different view. I may have many columns, but I'm more interested in ISBN book title page count here for a particular report. Book title, as I said, Amazon, for example, I just queried based upon only that I'm interested on iPhones. So it will list all those data only. There's a view of not the view of the entire database is very big. I'm not interested in all that. So in some other view, I may be interested only in book title, category, and price. Program data independence. So these are the things, when I say layered architecture, see the meaning of the layered architecture is that there is particular kind of work which is being done in each level, right? And you can see the arrows here. That means they interact. This is the interface between the logical and the physical interface between this and this, maybe through queries, through SQL queries, For example, as I said, iPhone, this is my keyword or the search string, right? So this search string based upon this, there is a query generated. So I have my SQL statement, select name, price, specifications from product table, where company, the manufacturing company is Apple. OK, where company equals Apple. So Apple based products, not necessarily iPhone, all the Apple based products could be. If you want only iPhone and correct and condition can be put. So Apple based products plus under Apple based, I am interested in iPhone and not iPad and smartwatches, etc. Or depending upon your query string, you can get into any of the things required. So that is what I am trying to say, that each layer has its own way by which things are done. So conceptual level, we build the database. Physical level, how it should be stored, what kind of indexing for faster retrieval has to be mentioned, all that will be worried. Tomorrow, you may want to change something here. You may want to change something here. You may want to change something here. No problem. It will not affect the other layers. We can still use the same. That is what we call it as the program data independence. So each level has its own independence. When schema at one level or layer is changed, only the mappings between the schema and the higher level need to be changed, but not other things. Okay, and the higher level schemas are unchanged. That's the advantage of having layered architecture through which I can achieve this independence. That means program is different, data is different. That's why we call it as the program data independence. To explain this, I have a very simple diagram or the example here. Let's assume that we have three teams here. The center application has to be built after the other two. So for the moment, assume that the middle one is not there. Only this and this third one is there. So we have some programs like P1, P2, P3, which is built by using these data A, B, C, D, E, F, G, H, I, J. Similarly, we have another team called as R team, where we have three programs built using this data RSTUV, all that. Okay, now assume that. So this is for writing into the database. This is for read write. This is for read write, like that. Assume that now we have third team called as Q, which is added, which has its own data plus which own data means D, E, F, M, all that. Sorry, not that, M and N. Not first of it, this one. M and N is the new data for this. And this team also requires data from the other teams. So it should be shared. How it is shared? So this fellow has to copy. You can see here D dash, E dash, all that. So this DEF is, copied and put for his own purpose. Similarly, RST is copied and put for his own purpose. And this is a wastage of memory because it could have been shared from here only. But the problem is that it is not so easy to share. Okay, problems of shared data. So unless and until I have a unified way of storing my data and make use of the shareable kind of thing without any integrity constraints and other security problems, then it's going to be a big issue. So look at this figure now, where now I don't have individual storage for each of the teams. I have my centralized database and a database management system in place, and people are not worried about program development by using any of this data. All are available to all these people, read or write. So this entire thing is taken care by DBMS. So that is the advantage of denillating. That means separating out program and data. This which we call it as the program data independence. That means data is not tied to the programs, but it is made as a central kind of repository, and DBMS helps in providing the base by which they can handle it.
So that's what explained here. The program, we call it as the logical data enable. That means whatever changes you make in the middle layer or the conceptual layer, no need to change any of the other layers except for the interfacing ones. Similarly, whatever changes you make in the physical, you don't need to change. So this is the details regarding what I've just now explained about the program data independence. Right, so now we'll go into the component system where we have we have the complete architectural diagram, which I'll show you after this. So we have many components involved in this detailed one. So instead of going through that, I can just show that. This is the complete architecture of the database management system in general. So it's not pertaining to Oracle or MySQL Server or MySQL. Typically, any database management system which you take, it will have these components. And it follows the three schema architecture. For example, this is your physical layer. This is your conceptual, this is DBMS, and this is your external view. Okay, so we'll start from bottom again. You have the data being stored in the data files, and you have the catalog, which is the meta information about all these database. And so this we call as a database. Coming to this DBMS, so this is the DBMS which has many components. So you have the SQL engine here, which in turn consists of plan, executor, parser, operator, evaluator, optimizer. What are these things? So quickly, let me just explain this. Now, whatever the queries which you get from the external world, that means in the form of web or some front-end applications or a separate high-end SQL interface, etc. So anything may come. That's what I said, the Amazon e-commerce kind of thing. You may want only iPhone, so you just type in that iPhone keyword in the search box. So that is through the front end. Front end is nothing but the graphical user interface, which is provided for the users to interact with the database or any application, maybe through web forms or mobile phone applications, etc. So this is converted into an SQL statement, like as I said earlier, it should be processed. How? So it should be parsed. So we have a parser, that means look for errors if any. And we have plan executor. This is a very complex process which many DBMS makes use of in order to execute the SQL statements faster. Okay, I'll show you the couple of slides later because it uses some intelligent way of executing this queries very fast. Operator evaluator, again, we have mechanism to evaluate any SQL statement by using some methods like SQL tree, optimize tree, etc. So optimizer is one. Again, by using an appropriate logic, we can make things faster. Like as I said, we have the query tree or cost-based optimization, etc., so that the queries could be processed very fast. So SQL engine is a complex module which parses, that means looks for errors or bugs and reports the error. If no error, it has to be executed very fast, for which it uses some intelligent way, etc. Coming to the transaction manager, it's for the execution of the statement. So we have a separate chapter on this called as concurrent transaction processing using a transaction manager. That means there are millions of transactions. Transaction is nothing but a set of statements in the micro level. That means macro level, we call it as a transaction. For example, fund transfer. That means transferring an amount from one account to the other is a transaction. Placing an order in Amazon or Flipkart is a transaction. So it involves with several micro level operations like access files from the database, etc. In order to process this, we also need what is known as buffer management. That means the data may have to be brought from the hard disk to the buffer. That means RAM. Or if you don't have enough space in the buffer, that means RAM, then you have to evacuate that and then make room for the new blocks or the pages which need to be brought from the hard disk. Because remember, buffer size is normally smaller compared to the hard disk or the database size. For example, we talk about 1 TB or 2 TB in a hard disk kind of thing where my database is stored, but here it could be some 4 GB or 8 GB RAM. That is your buffer. Same thing is true even in mobile phones. Okay, so that's how we 4 GB RAM or 4 GB bar 128 GB. If you go for 256, you have to pay heavily. So that is external memory, they call it in the mobile technology, mobile phone technology. But here it is a desktop or laptop. We talk about hard disk and this one, RAM. So buffer management is very important in order to make room for the uh, data being brought from the tables from the database storage to the buffer. So we have some policies which need to be followed. So I'll talk about this later again. Lock manage for concurrent transaction processing, because when you try to access a particular page in RAM, some other transaction should not be able to access it. So we just lock that. So once the processing is over, it will unlock. So we have lock management using what lock manager. So this again we'll study in transaction processing. We have binary lock, a shared lock management, 2PL, two-phase lock management. So many protocols, algorithms are there. So any eventuality of some things which are down, recovery manager will take. So we have the recovery manager as well. So the same thing now it's given in some other form by Navati. So that's your textbook. So we have a lot of utilities which are part of the commands nowadays with the tool or the framework. You get this loading, backup, recovery, similar to mobile phones, settings you have no. So similar to that, even here you have. I'll show you maybe in the next class some of this in the MySQL. So backup, recovery, all that. Storage manager. So this is the query processing. So how Oracle actually manages to parse, optimize, and evaluate the query. Okay, so you have your query, and then you have the parser, which looks for the errors, and then relational algebra. So this is another chapter which we'll talk later. So it converts that and optimizer. So it produces what is known as execution plan, which means that 2 or 3 ways of doing it can be done, and it will estimate which is better and then try to follow that as an execution plan, and it's evaluated and the query is output. So all these things are mainly to make sure that your query is executed fast. So alternate ways of the cost difference, that is cost-based optimization. Transaction management, I already told you. Why concurrently the transaction need to be executed? Because to achieve speed. If you execute sequentially, it's good, but the problem is it will take time. Concurrent, it will toggle between 2 or more transactions in order to make sure that it is made faster. See, each one is a chapter by itself or each one is a module by itself. So that time you will understand. So there are several people involved in the database environment called as database users. There's another separate user called as admin. That is database DB admin. Similar to operating system admin, we have here also. So you can see here database administrator. Where is my cursor? Yeah. Database administrator is responsible for several things like creation of user, manage the user, etc., etc. And as far as the normal users are concerned, yes, we have a lot of users in the category of sophisticated application program name users. The name users are okay, casual users, people who use the database occasionally, name users, constantly querying day-to-day kind of thing like booking clerks, all that. Nowadays, I think these are all gone. We do ourselves. So we are the clerks. Some people, anybody can do it now. Name users also can use it because apps are designed to make things easier. Sophisticated users, people, knowledge workers, we call, scientists, business analysts, all that. Standalone users who maintain a personal database also you can create your own. In fact, I have my own databases for my personal use. It's not for many other people, whereas commercial applications are mainly for all. So coming to data model is an abstract procedure that hides the, so it's an abstract model that extract information which is used in order to design a database based upon some logic or model, right? For example, a mathematical model. So in this case, it's a relational model, let's say, or it could be a network model, or it could be hierarchical model, or it could be object model, object oriented. So Oracle, for example, is an object oriented relational model, etc. So data model is the way by which we want to store the data. You can have your own model. You can design your own model, new model. Okay. For example, hierarchical model follows what is known as the tree structure. Okay. Whereas network model follows what is known as the graph based one, which is mainly useful for Facebook kind of thing. In fact, some of the NoSQL databases are based upon this network model. Okay. They don't have specific schema, NoSQL. Schema is more flexible, modifiable for each record or each row or each entity. So for example, here the advantage of having the network or the graph based model is that you can just like in Facebook, you can find friends of friends, like that. Who are the friends of say Jack in this diagram? Jack's friend is Mac, Harry, Howard. Okay. But Sam may not be a friend of Jack directly, but maybe via Annie. So that's what we see in Facebook. Okay. So such kind of complex relationships can be easily obtainable using network model. Similarly, object-oriented data model, everything is treated as an object. ER model is mainly to design the conceptual design of any specific database application. Our next contact session is going to be on this. So let me not spend time on this. What is entity? What is relationship? Why do we need this? How it's going to be helpful for design an application, database application. So how does a database application will look like? All these things we'll see in the next session because we have a separate. So the next one, contact session 2, you will see this. It's meant for that. So ER model is mainly a model which is used to develop the conceptual design of any specific database application. So relational model, rows and columns. For example, employee table. What are the columns? Employee ID, employee name, job, etc. So this is the structure which we follow. Rows indicate Each row indicate an employee or record, row, tuple. All these are same. Okay. So I want to store employee data in relational model, which is nothing but rows and columns. So this is the oldest kind of data model being used by many databases even today. Oracle, MySQL Server, MySQL, whatever it is. So there are separate languages being used, but actually all these will come under one single language called SQL or structured query languages. In that you have various statements which are separated based on DDL, data definition language, in order to design your schema. Then you have that is tables, table structure, etc. Then you have DML, that is data manipulation language, where you can change your add records, modify records, all that. Control language, DCL. So you can have privileges. That means you can create users, you can modify the constraints. It's all based on the user level controls. Transaction based commit, saving, transaction execution, abort. You can abort a transaction. Like there are several statements coming under transaction based manipulation. Okay, so these are all these things will come under what is known as SQL, structured query language. So we have, I think, separate one or two contact sessions for SQL, basic and advanced. Simple SQL state. So the entire database management system is the heart of your DBMS is SQL, because you interact the database management system with only SQL statements. Okay, either for creating your schema or manipulating your database or control your users or make some of the storing and retrieving, taking backup or restoration. Any of this normally is done by